Forge is Autodesk's cloud development platform. The Forge platform is a set of web service APIs that you can use to build innovative, cloud-powered applications. Forge APIs help you tap into your design and engineering data, which means you can streamline and innovate how you work. Whether you want to build solutions that automate processes, connect teams and workflows, or visualize your data, the Forge platform can help you do that, and so much more. Today, companies are using Forge to build digital twins, visualize and analyze data, render photos to 3D, integrate AR and VR, create product catalogs and configurators, automate design processes, and integrate SaaS products. Forge empowers developers and innovators from concept to completion. People across industries and companies of all sizes use Forge to unlock their data, improve collaboration, and build new services to address today's connected customer. Try Forge for free today.
You're crazy, is what I would have thought. There was no way. I know for myself, when I first became exposed to what we were planning with Forge, I was thinking, this is huge, right? It's huge in several ways. Convergence between industries, it's a big thing here. And as the industries converge, well, it's kind of obvious that then the tools will have to converge too. Giving our customers those tools to be able to be more creative, to have more ideas about what they might do, and to not be constrained by tools. It's a new mindset, and it's kind of like a revolution in my mind.
So let's take a big step back. The internet really became something for the masses starting in 1995. That's when Netscape came out, the very first mass market browser. Frankly, you couldn't do 3D graphics through a browser until WebGL happened 10 years ago. At the same time as 3D becomes possible on a browser, the design-make industry is migrating from 2D to 3D. And it's about accessibility. It's about being able to share 3D with anybody. All of a sudden, we, Autodesk, recognized we could put this 3D information up on the cloud as our first web service. And very quickly, we were told, I like the viewer, but there's a lot of web viewers out there. What I love is the data, because the metadata allows them to count, schedule, plan. It's funny, we put it out there initially as the Autodesk viewing web service, and then we quickly pivoted and said, it's the Autodesk view and data web service. And then recognizing that, there's more services we could provide. It's not just the view and data, we can do more.
Or we want it to get to a place where a cloud-based model makes design data as accessible as any data we know, as accessible as a Twitter feed is, but also is safe and only shared when people want to intentionally share it. And as we look at the world of things that are being made, we have people who need data and information and people who have that data and information. Science fiction throws that problem away. The thing that we suspend belief on is how hard data exchange is. Forge is the platform for how we do that.
It was time to have a coming out party. That's really what the first DevCon was. I've done conferences with 400 or 500 people, but this is on a totally different scale. It was amazing.
They not only get it, they're now telling us, the parts that we couldn't have imagined.
One of our early adopters, one of those first 200 users, Jay Dunn was at the conference. It helped them to connect cost estimating, to connect purchasing, to connect bidding between the design with what Jay Dunn had built. It helped them on their bottom line, not bidding things wrong. And it helped them on their top line, winning deals because the customers saw what J.E. Dunn was doing and said, I can trust these people. They have better data. They are not winging it. They are, the prototypical data-driven construction company.
Yeah, so afterwards, post-DevCon, first there was a sigh of relief. Next, after that, we were looking at, okay, so what happens next? We had to taper our enthusiasm. When you can see that a future is possible, oftentimes we want to run to that future. And that's what we have to sometimes hold ourselves back on and solve the problem that is today.
People need to trust us, whether it's a partner, whether it's a customer, they need to trust us. And they deserve that from us. So we had to take the time to do that. And we had to take a step back, and we basically took a breather for a year and a half, 2 years, to do a bunch of replumbing, to enable scalability. I like to, a quote I've used many times, innovation happens and it tends to happen elsewhere. And you kind of go, huh? Well, look, at Autodesk, we have 4,000 engineers. The Forge ecosystem today has about 7,000 or 8,000 engineers. That's a lot of smart people.
Many product teams use Viewer, and they were requesting more features than the other developers and I could implement ourselves. I realized we needed to change the narrative. Instead of treating the product teams as customers, we could treat them as collaborators. To give our collaborators a forum to following their own interests and explore new avenues, I organized the first LMV hackathon. Participants from various teams build creative projects that we might not have ever built ourselves. All of these examples ended up being productized and actually shipped with the Viewer now, which is super exciting. CC Tech is a great example of a customer pushing the boundaries of interactive visualization. CC Tech decided to use Forge Viewer to show airflow and fluid flow animations in the context of a 3D model. Wow, this is not what we planned to build Viewer for. That was again the change of mindset. Do not wait to provide a polished product to your customers, but instead they will help you to change your product in a way that your customers actually need, instead of not what you think they need.
Our customers might think of Forge as something that provides just a few APIs to them, never enough. I see it as something much bigger, and I see the direction we're going as much bigger. Beyond adding more APIs, we're going to see a far more modern, far smoother, and just much more workable approach for our customers. What that means for our engineering community is we can't distinguish and say, this one's a desktop engineer and this one is a cloud engineer. We really need both to understand both sides.
So there's a several-year job in front of us to show customers Forge is a set of web service APIs and allows customers to move design make data across an enterprise, to create digital transformation, to allow customers to just do a much better, faster, easier, lower cost job for whatever they happen to do.
As we move from a product company to becoming a platform company, we're making our software, our IP, available to far more people. And these people, they're going to do amazing stuff with it without loss of data fidelity, without tedious and error-prone human intervention. You did what the tool allowed you to do. Now we're just blowing that all out and giving people the space to be much more creative. And it's such a bold move of Autodesk's because, we're successful where we are. And with a change like that, we're taking a risk. And I'm so proud to be part of that journey.
So the value I see with connecting all this data, instead of having it as disparate sources where honestly we're sending URLs and people to different websites in different places, I can have a single point of contact with my customer through the Forge platform where they can log in, come to a website, see their projects, see all the data that's aligned with their projects. And if they can self-serve that from the Forge platform, it makes it an easier decision for me to invest in.
Hello, my name is Peter Brass. I'm a Forge developer advocate at Autodesk, and in this lightning talk, I would like to share with you a quick way to optimize your Forge to Unity pipeline. There are two ways of bringing your Forge models into Unity. You can use the AR/VR Toolkit service that is hosted by Autodesk, which allows you to bring both the geometry as well as the metadata of your designs into your own Unity application. Or you can use a Node.js library that can take the SVF format, that is the Forge 3D Exchange format, and convert it into an open 3D Exchange format called GLTF. You can either integrate this Node.js library into your own application or use it as a command line utility. With GLTF files, you can then leverage an ever-growing rich ecosystem of different kinds of utilities and applications. For example, loaders, be it for Unity, Unreal Engine, 3JS, or any other rendering engine, or various kinds of mesh optimizers, as we will see later. Also, the Forge Model Derivative Service is considering adopting GLTF as one of its native output formats in the future. Therefore, going forward, if you're interested in bringing Forge designs into Unity or Unreal Engine, we recommend using the latter approach. The goal of this lightning talk is to use the GLTF converter library, optimize the GLTF outputs for both loading speed and rendering performance, while maintaining the support for hovering, picking, selecting individual design elements, and retrieving their metadata from the model derivative service. Typically, AEC designs and manufacturing designs consist of a large number of small parts. This has often a very negative impact on both the loading speed and the rendering performance. This is often addressed by mesh compression and/or consolidation. Mesh consolidation is a process where multiple meshes sharing the same material or rendering surface are merged into one and rendered using a single GPU draw call. In the GLTF ecosystem, there are two popular libraries for compression and consolidation, Draco and GLTF Pack. In case of Draco, meshes of individual GLTF nodes are compressed, bringing a significant reduction to file size and therefore improvement to loading speeds. In this case, you can see a file of roughly 50 megabytes being compressed down to roughly 10 megabytes in size. However, since the number of objects in the optimized GLTF file is the same, there is often little to no improvement to the runtime rendering speed, as you can see in the FPS counters. With GLTF Pack, however, both compression and consolidation is used, which brings even better compression and reduction in file size, therefore improvement in loading speeds. And the mesh consolidation also improves the rendering performance. These improvements come at a cost, however. When multiple meshes are merged into one, you are no longer able to hover or select individual elements of your design. There is a way to work around this, however. When generating GLTF files, you can encode object IDs as vertex colors into the GLTF geometry, as shown in the script. The vertex colors remain available even after compression and mesh consolidation. Later on, when loading your optimized GLTF files into Unity, you can detach the vertex colors from your geometry to avoid the vertex colors to have an impact on the actual appearance of your objects. And you can cache and store the vertex colors for later use. And ultimately, you can use the standard Unity mesh functionality and APIs, for example, when doing hit intersection, to find a triangle of a mesh that's been intersected And for that particular triangle, you can retrieve vertex colors and decode them back into object ID. We built a small prototype that showcases this functionality, where a Revit design has been converted into GLTF file, optimized and consolidated using GLTF pack, and in Unity, the user is still able to point at individual parts of the design and retrieve their object IDs. The sample code of this application is available on GitHub. Thank you for your attention.
At OpenBOM, like we said, bill of materials, it's a lifeblood of manufacturing. So what is important is to all people in the company to get connected through the data. So engineers are sending information to procurement. Procurement is connecting to suppliers and contractors. Multiple engineering teams are working together. So all these teams are basically working on the top of the data, and OpenBOM gives them a platform. Like we say, they need to stay on the same BOM to operate efficiently. So that's why there is tremendous importance in data.
Hi, I'm Adam Nagy, a Forge developer advocate, and in this Forge Lightning talk, I'm going to show you one of the best ways to explore this API. You will find the Fusion Data API documentation at the given link, which provides you with a nice overview of the capabilities, tutorials, samples, and also a list of all the objects that are exposed. One of the samples also has a live version that lets you log in using your Autodesk credentials and play with the Fusion Data API. This is a great way to explore this API. The steps in the tutorials are also using the Fusion Data Explorer. You should check first the About Fusion Data Explorer section, then go through the step-by-step tutorials using it. Let's check out quickly the Fusion Data Explorer by going to fusion-data-explorer.autodesk.io, where you can simply log in using your Autodesk account. You also have to enable the application's access to your data, so click Allow. On the right side, you will find the Documentation Explorer that lists all the queries and mutations that you can use, including the hubs query that is offered in the editor by default. When you hover above any of the objects in the editor, a pop-up will provide a short description and a link to the relevant part in the Documentation Explorer, where you can find more information about them. You can run your queries using the play button, and as you would expect, the hubs query returned all the hubs we have access to. We can also filter results to specific items, in this case to a specific hub that we are interested in, using the filter parameter. One thing we tend to do, which is similar to how things are done in a programming environment as well, is that we take advantage of query variables. We can simply create a function, name it whatever we want, declare the variables we want to pass to it, and then provide their values in the query variables window. When typing, IntelliSense will automatically offer the required variable's name, and then we just have to set its value. When we rerun the query, the result is the same as before, just as expected. You can always get help by hovering above any of the objects in the editor. As you can see, the returned hub object also has a projects field that returns all the projects the hub contains. So let's find the name of all the projects in our hub. The filtering mechanism that we used for hubs is also available for projects. So let's declare a variable for that as well, called project name, and provide its value in the query variables window. When we rerun the query, we only get the project we wanted. Now let's see what files and folders are available inside the root folder of the project. We can ask for the name of the folder, which should be the same as the name of the project, then get the lists of items in it. We'll also ask for the type name of each item so that we can see if they are a folder, component, design file, or something else. As you can see, only the first item is a folder and the rest are components. The steering wheel model will be really good for testing as it references multiple other components. So we are going to be filtering for that specific component the same way we did for hubs and projects. As I mentioned before, you would do things exactly the same way in a programming environment. Use a function, declare input variables, and provide their values in the query variables section. We can even copy-paste the query from any of the samples and run them in the Fusion Data Explorer. In this query, we are accessing the latest version of a component using the tip version property and getting its ID. We can of course ask for other properties as well, like name, part description, and part number. I chose this model because it references multiple other components. You can get a list of those using the model occurrences property, then get to the specific version being used through the component version property. Then we can access properties like name and part number, just like we did for the root component. And here is the list of all the components used by our steering wheel design. Finally, a list of resources that will help you get started with the Fusion Data API. There is the online documentation, of course, the GitHub repo with the samples, the 2 online utilities that let you play with the API, and the link providing info about how you can contact us if you need any help. I hope you found this presentation useful and it convinced you to give this API a try. Bye for now.
Hello, my name is Erica Buffert, Senior Product Manager for Developer Experience here at Autodesk. Today, I want to introduce you to the improved Create App workflow in the Autodesk Developer Portal. The improved experience is part of our year-long initiative focused on making it faster and easier for developers to start building on the Autodesk platform. We talked to new and experienced developers to get their feedback on how we might improve this workflow. Based on their responses, we focused on the creation and editing of application profiles on the portal. We reduced the amount of information initially needed to create an app and added a couple of additional features to give more flexibility in configuration and management. Let's take a look. I'm starting on the new application screen, previously called My Apps. As we go through the demo, I'll highlight a few other changes that we have made along the way. We've modernized the look and feel of the application, smoothing out the rough edges and generally making it easier to interact with. For example, to get started creating an app, now all I need is to add a name. Once the app is created, you can update the information provided by default and fill in optional fields. Now let me highlight some of the new features. Secret regeneration is now a 2-step process. First, you generate your new secret. After secret regeneration, both your old secret is still being used for authentication, but now you can update your code with a new secret on your schedule. Typically, we recommend that you put in some sort of fallback switch so that your code is first testing for your new secret and then your old secret. And that way you can seamlessly switch without having any interruption to your service in the meantime. Once you've updated your code to add in that fallback logic, you can come back to the developer portal, click Use New Secret, and then your new secret becomes active. We also now explicitly indicate the grant type given to this application, and we provide a description of what this means and some implementation guidance. You can see that here. You may also now specify multiple callback URLs, meaning that you can build an allow list of callback URLs for use with any API that requires 3-legged authentication. As part of our modernization of the app look and feel, we've made it easier and clearer to select which APIs you want to authorize this app to access. Finally, we've sort of moved and restyled the delete functionality to reduce the likelihood that somebody accidentally clicks on the button and deletes an application in error. We hope you enjoy the new app creation experience, and if you have any feedback, please reach out. We always value hearing from you. Thank you.
It's becoming more and more possible for average people to build tools. You don't have to specifically, let's say, work for Autodesk or have studied tech. I saw a lot of people in there with all sorts of different backgrounds all ready to build something. And I'm in the AEC industry, so it's kind of neat to see that in technology.